Hi everyone, this is Teacher Jane again, and my lesson for today is all about proving the geometric properties using the distance formula. The examples that I'm going to discuss were lifted from the Mathematics 10 Quarter 2 module, pages 26 to 29. My topic for today is very timely and suitable to the distance learning that we are experiencing right now. But with all these apps that are available, we can now connect with one another even though we are distant from each other. Now let me start my discussion with this question. How is a screen size measured? Have you even bothered to ask this to your store salesman? Remember, the bigger the screen, the higher the price of the TV. Now it pays to have a knowledge on this one. The screen size of your television set is measured by its diagonal. The diagonal is the segment that is formed from one corner to the opposite corner of the TV set. So in this case, this is measured as 32 inches, which reminds us of the concept of the Pythagorean Theorem. Let me move on to the Pythagorean Theorem. Did you know that the distance formula is simply an application of the Pythagorean Theorem, which states that a square plus b square is equal to c square? Now, who is the author of this theorem? He was Pythagoras from the island of Samos, Greece in 569 BC. He founded a group called Pythagorean Society, and this was one of the communal ideas that the group was able to come up with. And later on, it was named after Pythagoras and called the Pythagorean Theorem. Now, how does the Pythagorean Theorem work? The formula a square plus b square equals c square is applicable to the right triangle, where a and b are the legs of the right triangle, and c is the hypotenuse or the side that is opposite the right angle. A and b can interchange but not c. So let us now use this formula in solving this. Let me show you how to use a square plus b square equals c square in finding distances. So for example, let us pick a point on the y-axis, okay, and let's call it point A. Okay, so you have here point A, and you will go to point B. Now, the distance traveled from point A to point B, okay, denoted by this red mark, is simply 4 units. Okay, and example is from point B, you want to go now to point C. Okay, let's call this point C. Okay, and this distance is simply 3 units, because you only have to count the number of grids that you're able to go through. But since you from point C you want to go back to point A, of course the shortest distance is of course the straight distance from C to A, and not to go back to B then to A. So that short distance, okay, let me color it red, is from point C going to point A, which is something that you cannot count from either the x-axis or the y-axis. So in this case, we are going to use the Pythagorean theorem. For here, since it's one of the legs of the right triangle, we can now refer to it as our B, and 3 is A. So A and B can interchange, but in this case, I'm going to choose 3 as my A and B, okay, and 4 as the B. But since C, or the one that is being asked, is opposite the right angle here, therefore that is C, or the hypotenuse of the right triangle. Now, applying the formula a square plus b square equals c square, and for me, it is much more comfortable to switch this formula into c square equals a square plus b square. I'm going to substitute now, okay, and I switch already. This is A, okay, and this is B. So I have 3 square plus 4 square. Then evaluating, you have 3 square is 9, 4 square is 16, then add, C square is equal to 25. But we are looking for C, so we are going to do the opposite operation, and that is by extracting the square root of C square and the square root of 25, which is 5. So the length here of C is 5 units. Okay. Now, going back to this problem, this can also be solved in another way, which is with the use of the distance formula. Now, the distance formula is definitely from the formula of the Pythagorean, which states that this time we are going to extract the square root of C square. That's why it is now C is equal to the square root of A square plus B square. Now, to simplify things, or how to get A square here, your A, okay, is now x sub 2 minus x sub 1. Okay, how did this happen? Okay, this is your A, and this has a coordinate of 3, comma 0, and your B has a coordinate of 0, comma 0. Notice that the length is 3 because you simply subtract the x. Okay, 3 minus 0, and that is 3. So that is for A. Now, same thing with y sub 2 minus y sub 1. It is represented by B because if you notice here, this has a coordinate of 0, 4, point A, and then point B has a coordinate of 0, comma 0. Notice that you simply subtract the y's. Okay, so 4 minus 0, and it gives you the length of AB, which is 4. So simply, the distance formula was derived from the Pythagorean theorem. So let me move on now to using the distance formula in solving distances in my next example. Moving on, let's have example number 1. Find the distance between A at 0, 4 and C at 3, 0. So in order to visualize this, I was able to show you the graph of A and point C. But this is actually not necessary when you are using the distance formula. Okay, step 1 is to assign values, which one is P1 and P2. So let me choose A as P1 and point C rather as P2. So therefore, since point A is P1, point A will now be x sub 1 and y sub 1. While P2, point C, will be our x sub 2, y sub 2. Okay. After assigning values for each of the points, we will now move on to writing the formula. D equals the square root of x sub 2 minus x sub 1 square plus the quantity y sub 2 minus y sub 1 square. Now, substituting for x sub 2 and x sub 1 and y sub 2, y sub 1, we simply have, so this is now x sub 2 here, 3, and minus 0, which is our x sub 1 here, plus y sub 2, okay, is 0, minus y sub 1, which is 4. Okay, then evaluating everything inside the parentheses, we get 3 minus 0 is 3, 0 minus 4 is negative 4. So therefore, we have 3 square plus negative 4 square. Okay, 3 square is 9 plus 16, positive 16. Then we add, we have the square root of 25, and the answer is 5 units. So it's the same as the one we got from using the Pythagorean theorem. So that is how to use the distance formula, okay, in solving the previous problem that we had using the Pythagorean. Example number 2. Find the distance between point A at -5, 1 and B at 3, 5. Okay, so this is point A at -5, 1 and point B at 3, 5. And we are looking for the distance from A to B. Again, graphing is not necessary in this case. Now, step 1 is to assign values. Okay, in this case, I'm going to choose B, okay, as our P1. So, therefore, this is our X1, Y1, and A as our P2. So, this is now X sub 2, okay, Y sub 2. So maybe at this point you're asking, can you interchange, okay, P1 with P2? Yes, definitely. But remember, when you interchange them, for as long as you assign it as X2, it should be paired with Y2, and X1 have to be paired with Y sub 1. Okay, so next step is to substitute to the formula x sub 2 minus x sub 1 square plus y sub 2 minus y sub 1 square. So by substitution, so this is x sub 2, okay, here, minus x sub 1, okay, square, plus 1, okay, this one, minus 5. Okay, remember, you have to carry the sign of the coordinates. If it's negative, you have to write negative. Therefore, dealing with the values inside the parentheses, you get a -8 square plus -4 square. Evaluating this, we get 64 plus 16. Then we add square root of 80. Then you have to use your calculator to get its decimal value, which is 8.94427,191. Then up to the hundreds, we get 8.94 units. So this is the length of segment AB. Now let us now move on to the last example. The last example is actually proving a geometric property about the diagonals of a rectangle, which states that the diagonals of a rectangle are always congruent. So number 3, in rectangle MATH, the vertices have coordinates M, -4, 5, A, 3, 5, T, -4, 0, and H, 3, 0. Prove that the diagonals MH and TA are equal. Now, it is necessary to graph this problem. So I have to graph it here so that we can visually look at our rectangle MATH. Then I'm going to draw the diagonals of the rectangle MH and TA. So this is MH, okay, from M, B connect to H, and from T connect to A. So we have to prove that TA is congruent to MH. Okay? Now to prove this, the plan is to use distance formula, although this can also be solved by the Pythagorean theorem, but in this case, I'm going to show you, okay, how to solve this using the distance formula. So simply, we are going to solve the length of MH, okay, and then we take note of that, and then we are now going to solve for the length of TA. And if we are able to prove that their lengths are equal, therefore, that is already a proof that MH and TA are equal. So the formula for distance is x sub 2 minus x sub 1 square minus y sub 2 minus y sub 1 square. We solve first for the length of MH. So by substitution, we have 3 minus the -4 square plus 0 minus 5. Now dealing with the ones inside the parentheses, we have 7 square plus -5 square. So the answer is 49 plus 25, and that is square root of 74, which has a decimal value of 8.6023252670 or 8.60 units. Now we will move on now to solving the length of TA. So TA, when substituted to the distance formula, will have negative 4 minus 3 square plus 0 minus 5 square. Then dealing with the ones inside the parentheses, we get negative 7 raised to the second power plus negative 5 raised to the second power. Evaluating them, we get 49 plus 25. Then adding 49 plus 25 is the square root of 74, which is equal to 8.6023252670 or 8.60 units. Since segment MH is equal to 8.60 units and segment TA is also 8.60 units, therefore, segment MH is equal with segment TA. Now with this, I hope I was able to prove that the diagonals of the rectangle are indeed congruent or equal. I really would like to leave a beautiful message to all the learners out there that everywhere is within walking distance if you have time. And for those who keep on watching my vlogs, thank you very much for watching and please click the button to subscribe, please. Thank you.